Okay, welcome to another sample problem that's supposedly similar to what we might see on the PSSA. Let me just make this a little bigger here. All right, so we've got a bus and another bus. So Sophia's boarding her bus, and it says she boarded a bus at the bus stop. The distance traveled by Sophia's bus is represented by the graph below. So here's a representation of Sophia's bus. We can see that 0 time, 0 distance makes sense. And then obviously the slope of this line is going up at a steady rate because the bus is traveling at the same speed. And we can see a couple of points here. We can certainly see that after 10 minutes her bus has gone exactly 6 miles. If you look really closely, you can also see that after 5 minutes, right in between here, it's gone 3 miles. So definitely a constant speed, and it looks like the rate for Sophia's bus is constant, and it's basically a distance of 6 miles for every 10 minutes. Now we can just leave it like that for now. We don't have to make it into a unit rate or simplify it. Let's just leave it like that. All right, now let's look at the other bus. At the same bus stop, Barry boarded a different bus to school 5 minutes after Sophia. So they're leaving from the same place, but Sophia's bus leaves 5 minutes earlier, so her bus has a 5-minute head start. The distance traveled by Barry's bus is described by the table below. So here we've got this table. It's not as easy to see it visually as the graph, but we've still got some of the same information. So let's see if we can figure out the rate from using let's just pick 2 points. Let's just treat time as our independent variable. Time is always independent, or almost always. Y will be our dependent variable. So if I think of these as ordered pairs, I've got the ordered pair 7, 2.4, and the ordered pair 9, 4.8. And so much as we did a while ago when we were working with slope, we're going to try to find the rate for Barry's bus. And that's just basically the change in y over the change in x. So it's basically a slope problem. So to go from 2.4 miles traveled to 4.8, that's an increase of 2.4 miles. And to go from 7 minutes to 9 minutes is an increase of 2 minutes. So that means Barry's bus is going 4.4 miles in 2 minutes. Well, so which one's going faster? The question that we're really trying to figure out is, there's 2 parts to it. If the school is located 12 miles from the bus stop, which bus arrives at school first, and how fast is that bus going? Well, 2.4 miles in 2 minutes is really the same as 1.2 miles per minute. And if you think about up to Sophia's bus, she's going under a mile in 1 minute. If you wrote this as a unit rate, which we didn't do initially, but 6 for every 10 means 0.6. So her bus is going a little over a half a mile. Barry's bus is going 1.2 miles, so he's going literally twice as fast. In fact, I can't endorse this problem because this problem has Barry riding in a school bus at well over 60 miles an hour, which I think is unsafe. Nonetheless, it's in the problem, so we'll accept the challenge. It looks like Barry's bus will only take 10 minutes. If he's going 1.2 miles every minute, it's only going to take him 10 minutes to get there. But don't forget, Sophia's bus had a 5-minute head start. So even with the 5 minute, he spotted her 5 minutes, and he still gets there 15 minutes after Sophia's bus left. 10 minutes after he left, but 15 minutes after her. It's going to take her 20 minutes going at 6/10. I mean, if you think about it, to go 6 miles takes 10 minutes. So to go 12 miles, because that's the distance, would take twice as long, 20 minutes. So Barry's bus gets there, and he's going way too fast.